Okay, we start. We have to start at a certain point. It's great to have so many people here. I'm Henk Ovink. I'm the Executive Director of the Global Commission on Economics and Water and member of the Scientific Program Committee of Stockholm. And I'm here with my co-organizers, Alida Pam from the World Bank and Elise Blondel from the Commonwealth Secretariat. As well as our partners from IUCN, IMI, and Wetlands International, Maria Coreno, James Dalton, Matthew McCartney, Rodiga Giurascinia, and Paula Martinelli. We are super happy to kick off World Water Week Stockholm. Today on a Sunday early morning, I had my 6 a.m. early morning swim in one of the amazing lakes in Stockholm. And as you all know, World Water Week is about water, every aspect of water. And this is the first session out of our 3-session seminars about mitigating climate impacts through ecosystem resiliency. So really looking at how our ecosystems help us, one, understand how to mitigate and adapt to climate change, and how ecosystems functioning and their restoration and conservation can strengthen our climate action. There's a lot to say about it, and I'm super happy with today's session and panel, but it's, as said, it's the first, and it's about the role of water in the hydrological cycle in climate resiliency, focusing on the hydrological cycle's contribution to mitigation, to carbon sequestering, aquatic ecosystems such as wetlands, lakes, and rivers. And some of the case studies will show that the impact of green and blue water management, so transpiration and evaporation, so the water we see as well as the water in our ecosystems, our biodiversity, are key for our ecosystem as well as our societal, our community resilience. We also address the degradation of these systems. Unfortunately, we're not on the right side yet of the change that we want to see, and how that degradation is exacerbating climate vulnerability, but also climate change. So we have something in our, you could say, in our capacities to deal with climate through ecosystem action. The second session, which will be on Wednesday morning, we'll look at the water cycle as a pillar of ecosystem health, role water plays in supporting biodiversity in diverse habitats, innovative water management practices, not only to protect, but also to enhance biodiversity, and indigenous knowledge. We will have indigenous speakers, as well as understanding how indigenous knowledge and practice in managing these ecosystems over time really also not only show that there is a massive capacity there, but it is also about how you do it, the process of including communities and younger generations. And the last session, which is also on Wednesday, will be a workshop, very interactive, with different breakout rooms, tying our 3 sessions together and really looking at this nexus of climate, biodiversity, and water, and the water cycle. So not only blue water, but the full water cycle to shape a path forward towards this 2026 UN Water Conference that we will have next year. And as you might know, being one of the drivers behind the 2023, that 2026 Water Conference for myself as a water ambassador, of course, is key important. But that's Wednesday. It's now Sunday. I'm super happy that you're all here. Really look forward to do this session with you. We will start with a keynote, and then we have 2 guest speakers, and then we'll go in a Q&A with the audience that we have online, as well as with the speakers, to see how we can emphasize that role of water in mitigating climate. For the keynote, I'd like to turn to Noreen Anisha. She's an environmental researcher specialized in freshwater systems and their overlap with climate change. Water resource engineer by training, worked on several projects on climate change mitigation and adaptation in the water sector internationally. And currently, Noreen is a doctoral candidate in environmental science at Oregon State University. where her research is focused on understanding coupled human and natural systems dynamics in the wetlands of Bangladesh. And while Noreen is in Oregon, it's super late for her. So we're very happy that you stayed up to join us for this, our early morning session. Noreen, the floor is yours.
Thanks a lot, Hank. Thank you. And hello, everyone. It's a privilege to open today's dialogue on role of water system in climate resilience. And since I've been asked to kind of set the scene for the sessions, I wanted to kind of capture the essence of what it means to me about having water systems for climate resilience. So that's what I would try to probably talk about today. Well, as a professional in water resources and someone who comes from Bangladesh, which is one of the most climate vulnerable and water dependent countries in the world, I have both witnessed and experienced and worked on firsthand how water bears the brunt of climate change. And for too long, water has been framed only as this victim, this casualty of climate change, rising sea levels, devastating floods, worsening droughts, right? But I'm very encouraged to see that this narrative has been shifting for the last couple of years, and increasingly we are beginning to see water not only as this victim, but as this very big ally of building climate resilience. Much of my own research and work has been focused on understanding how freshwater systems, wetlands, rivers, lakes, floodplains, function in the global carbon cycle, and how to leverage these understanding to integrate them as in this freshwater systems for climate change mitigation. The systems are unique because they can act as both carbon sinks and carbon sources, depending on how they're managed and their condition. Degraded freshwater ecosystems emit greenhouse gases, while healthy systems capture and store carbon for decades and centuries. The challenge and the opportunity is to leverage the dual role for climate mitigation, minimizing emission while maximizing the sequestration. And despite the solid signs that we have for, say, global wetlands that take 6% of the global landmass, but is responsible for sequestering more carbon, almost twice as much as the forestry of the world. For, say, our rivers and floodplains, as dynamic as they are, they can be, emit greenhouse gases if mismanaged, but can also be, the capturer, the storage for carbon. And despite the solid signs that we have, water has been treated as this supporting actor in climate policy, when in reality it belongs at center stage. In most NDCs and national adaptation plans, water is mentioned, but usually as a risk to be managed rather than a solution to be mobilized. Climate finance will also tell you the same story if you look at that. This underrepresentation has consequences by sidelining water, particularly for their role in climate mitigation. We overlook one of the most powerful and natural levers for both mitigation and resilience. We also miss opportunities to connect climate action across sectors, such as food, energy, health, biodiversity, all of which actually are connected to and depend on water systems. Aquatic systems are crucial because their carbon storage benefits can be overturned to carbon emission due to mismanagement. It is important to consider their role in most climate action plans. You see the UN Decade on Ecosystem Restoration Action Plan calls on us to ensure that degraded freshwater, marine, and terrestrial ecosystems are under restoration and ensuring connectivity among them and focusing on priority ecosystems. The freshwater challenge, where now several countries commit to restore 300,000 kilometers of rivers and 350 million hectares of wetlands by 2030. There are initiatives that help governments integrate freshwater into national climate strategies and financing pipelines. So we see momentum is building, but commitments must be translated into actions. Things can change and things are changing, We are seeing community-led floodplain restoration, improved fisheries, recharged groundwater, stored carbon, reduced conflict in Mali's inner Niger Delta, which happened through water-based, water-focused nature-based solutions, urban landscape redesigned with water-focused nature-based solutions to reduce floods and cool heat islands and improve water quality in China's spawned cities. We have seen mangrove restoration, which has significantly reduced impacts of storm surges, while sequestering blue carbon and sustaining coastal livelihoods in Mekong Delta in Vietnam. We have seen high altitude wetlands, which are now protected by law, secure water for millions of people while buffering climate impacts in Colombia's Pea Ramos. So we're seeing their changes coming, but we need to, bring it more on the forefront, and there's still a lot of opportunities left. It is time to define more strategic and concrete pathways for action. We need to scale freshwater-focused nature-based solutions, invest in, peatland, wetland, mangrove, and floodplain restorations and preservations. These are very low-cost, high-return solutions that deliver carbon sequestration, climate resilience, and biodiversity benefits. We have to ensure freshwater ecosystems are explicitly part of NDC's national adaptation plans, global, local, national, and regional climate policies, action plans, and finances. And finance is a very important part because we see in climate mitigation financing, when we talk about it, the renewables and forestry and landscape has a lot higher financing or highlight than water. We have to strengthen community engagement and bottom-up approaches because resilience is built locally. That means, the participatory governance where communities understand and co-design solutions related to water-based mitigation and adaptation and create like a sync between these two, blending traditional and scientific knowledge, ensuring indigenous practices are valued, which, you are going to discuss in sessions in the future, scaling local innovations like there's flood resilient farming in Bangladesh or rainwater harvesting in East Africa, and bring them under systemic approaches. And we need to prioritize aquatic ecosystem restoration and climate commitments. Needless to say, design cross-sectoral water strategies that anticipate trade-offs between agriculture, energy, wash, economy, reform climate finance criteria to channel funds directly into water-based solutions, and mandate participatory planning in all major water projects, or most projects that are related to water, integrating community and indigenous voices. And invest in monitoring and data systems to close knowledge gaps on freshwater emissions and sequestration. And to be honest, the science is still very new. We, even a couple of years back, did not know much about how freshwater systems, emitted carbon or participated in the carbon cycle, or the role, there were a lot of knowledge gaps that we had to work on and we're still working on. And considering how central water is to climate issues, we need to evaluate development and climate resilient projects for the impact of water, for their impact on water systems and their role as carbon storages. And when framed correctly, water creates rare policy win-win. A wetland restored sequesters carbon, recharges aquifer, reduces disaster losses. A floodplain reconnected reduces floods, protects communities and economies while stores carbon. A spawned city restores infrastructure, cools urban heat, captures water, at the same time gives sequestration benefits. And it is time that water ecosystem must move from the margins of climate policy to its very heart. And that is something we can discuss in 2026 conference. And it's time to see water not only as a risk, but as the greatest ally in building climate resilient future. Thank you. I'll be open to take questions later.
Thank you, Noreen. That's amazing. It's great to hear from you, your insights and your current research, but also the examples you were able to share. For everybody, you can use the chat to ask questions, and we will collect them after the speakers for the Q&A. So thanks so much, Noreen, for kicking us off. Then I'll introduce our two speakers. First up is David Ellison, who's a senior researcher, forest resource management at the Swedish University of Agricultural Science, with a focus on forest evapotranspiration and the carbon and water cycle interactions. David, please, the floor is yours.
Great, thanks. Here I'm sharing my presentation, and I'd like to say thank you for the invitation. I really appreciate the opportunity to be here. Let me start out by just pointing out that in an article from 2012, I highlighted that the Copenhagen Climate Council made a statement about the future climate-related challenges, and they stated that if mitigation is about energy, then adaptation is about water. And at that time already, I suggested in this article that the council statement should be amended as follows. If mitigation is about energy, then adaptation is about forests and water. So I thus welcome the establishment of the Global Commission on the Economics of Water, and the attention it seems to be paying to the hydrologic cycle across land surfaces, as well as to the importance of wetlands and tree, forest, and vegetation cover. Many of us, myself included, have been calling for this kind of institutional framework for a long time. So the addition of forests and is crucial and pivotal in this framework. Water will become available across land surfaces at ever diminishing rates if we fail to understand that tree, forest, and vegetation cover are key to the storage of water on land surfaces. They generate infiltration and groundwater recharge, and to the circulation of recycled rainfall back into the atmosphere through the production of evapotranspiration. Both of these phenomena depend on adequate tree, forest, and vegetation cover. Without tree, forest, and vegetation cover, only atmospheric moisture which derives from oceans would contribute to rainfall over land surfaces. If this would diminish the total available supply of water on land surfaces by as much as 64 to 65% from what we currently have in terms of rainfall. In other words, we currently have approximately 2.8 times more rainfall over land surfaces because tree, forest, and vegetation cover help store and redistribute water resources across land surfaces and deeper into downwind continental interiors. Without the crucial role played by tree, forest, and vegetation cover, significantly less water would be available across land surfaces. On the other hand, by increasing or restoring tree, forest, and vegetation cover across land surfaces, we can simultaneously increase the storage of water on land surfaces, increase infiltration and ground and water recharge, as well as increase the circulation of recycled rainfall back into the atmosphere by increasing evapotranspiration. Generally speaking, more trees, forest, and vegetation cover is positive for the hydrologic cycle. So one of the principal problems with most forest landscape restoration strategies, however, is the failure to think about the role and importance of larger scales. So historically, forest hydrology and hydrology more generally has tended to focus on the catchment or the watershed scale and not look beyond those boundaries. This has had the effect of focusing attention on the water balance and resulted in viewing tree and forest cover as the principal cause of water loss. Moreover, in this framework, the roles of infiltration and groundwater recharge tended to be overlooked or ignored. Forest landscape restoration strategies need to think carefully about two things: how they impact infiltration and groundwater recharge at the catchment scale, and how they impact the larger scale supply side elements of the water cycle through evapotranspiration and precipitation or moisture recycling. Most forest landscape restoration strategies focus on small-scale projects at the subcatchment or subbasin scale. Few forest landscape restoration strategies, however, consider the larger-scale relationships That is, where the atmospheric moisture that produces rainfall comes from and where excess evapotranspiration produced at the catchment scale might go to further on down the downwind scale. Forest landscape restoration strategies and goals need to carefully consider the fact that they are embedded in a larger interconnected system. Most atmospheric moisture that comes down as rainfall over individual locations is primarily the result of upwind atmospheric moisture production, either from oceans and/or from tree and forest cover. As long as the upwind sources are adequate, more tree and forest cover will likely benefit the local catchment. But if the local catchment is water poor and upwind sources have been depleted over time through deforestation, adding more tree and forest cover will not likely resolve the situation. In fact, it could have actually relatively severe consequences. If, for example, the upwind catchment has previously been deforested and or converted to croplands or to urban settlements or both, this can result in inadequate water rainfall supply when forests are restored in an individual catchment. Likewise, since forests have historically been removed from many locations, reforesting upwind locations may be more beneficial than local catchment restoration. Finally, adding enough forest cover to produce ET for downwind locations is also an important consideration when planning and thinking about forest landscape restoration. The principal point is that we should think in far greater regional and potentially even continental frameworks when considering forest landscape restoration and its benefits for the water cycle over land surfaces. On the other hand, at the catchment scale, it is also important to think carefully about two things. One is what I call the minimum restoration threshold, which restores infiltration and groundwater recharge cycles. This maximizes at a sort of a midpoint of tree and forest cover across the landscape. But this doesn't necessarily define what we might think of as the optimal tree cover density, which is the second target. The optimal tree cover density essentially should focus on restoring the ET regime, the evapotranspiration regime, as much as possible. Both of these points are crucially important to restoring the hydrologic cycle across the land surface. Finally, I would like to turn to the relative importance of considering both the water and the energy cycle when considering forest landscape restoration. Too much literature focuses on the impacts of forest albedo. This literature tells us that forests, because they are dark in color, warm the landscape. Generally speaking, however, this is not really true. The forest albedo literature in particular typically ignores the role of clouds and the importance of tree and forest cover in promoting low-lying cloud cover over land surfaces. Forests cool both the land surface at the local scale as well as at the global scale, and they do this because they use incoming solar energy radiation to promote evapotranspiration production. As a result, the production of evapotranspiration heat energy is moved from the land surface into the lower atmosphere, and thus the heat energy is not able to warm the land surface. For this reason, well-watered forested areas are typically much cooler than surrounding areas with more limited vegetation cover and water supply. With adequate water supply, stored water, and additional rainfall, forests keep the land surface from warming up in the first place. Land surfaces without adequate vegetation, on the other hand, act as heat sinks and absorb more incoming solar radiation. The production of evapotranspiration from tree and forest cover also has the effect of moving moisture into the lower atmosphere, where it combines with other sources of atmospheric moisture and contributes to cloud formation. The albedo literature typically ignores the cloud formation phenomenon, and this is crucial. Clouds, in particular low-lying clouds, have the effect of producing white surfaces which reflect incoming solar radiation back out into space. This top-of-cloud surface albedo can have an enormous impact on global temperatures because it reduces the total amount of incoming solar radiation that can lead to heat formation on land surfaces in the first place. So we expect that the historical loss of tree and forest cover, this could be as much as 50% of the forest cover that we used to have, has had a very significant impact on Earth's energy imbalance. Thus, the restoration of as much tree and forest cover as possible would not only provide more rainfall and store more water across land surfaces, it would also have a very important impact on reducing total heat formation on land surfaces and thus on the global climate. For this reason, it is important not to overemphasize the role of forest albedo. Forest albedo is essentially a part of the evolutionary cycle of forests, which use this energy to produce evapotranspiration and thereby to grow. And this phenomenon also promotes additional cloud formation over land surfaces, which promotes additional cooling. Thus, as long as there is adequate water supply across the land surfaces, additional tree and forest cover will help provide additional cooling power both at the local and at global scales. As long as we realize that adequate tree and forest and vegetation cover is the source of adequate water supply across land surfaces in the first place, they store the water in the landscape, we can close the circle and use tree and forest cover as a tool to improve ecosystem function and thereby human well-being. And I will leave it there and return later to answer a few questions.
Thank you, David. This is amazing. Thanks so much for doing this deeper dive and really relating it back uh, uh, to get a better understanding of the hydrological cycle's importance in the context of our biodiversity complex. And thanks for referencing the work of the Global Commission on the Economics of Water. We were very happy with the Commission to get that understanding of the cycle in the context of our total vulnerability and, of course, the actions we can and should take. So also, thanks for showing that insight on where we should put our attention and indeed broadening the scope on how we look at the relationship between water, the water cycle, climate change and its origins, as well as its impact, and looking both at adaptation and mitigation, which we too often forget. So thanks so much. Okay, I'd like to turn to Max. Max Finlayson, great that you're here, professor, wetlands ecologist at the Charles Sturt University, with your focus on wetlands, blue carbon, biodiversity, and resilience. Great that you can join. You were not part of the start, so I was not able to ask you where you are, but really great to have you in this session. And I would like to open the floor for you and hear about your insights. And perhaps, Max, you should unmute or not. I'm not sure. I don't hear you.
Now we can hear. Thank you.
Yeah, perfect. Very good. Okay, the floor is
Thank
yours,
you.
Max. Yeah, kick it off. Yeah.
I'm talking to you from Australia, Southeast Australia.
Wow.
It's early evening here, so it's a very good time to be talking and joining your meetings. And thank you for the invitation. I want to, in this brief presentation, talk to you a bit about carbon in wetlands, some of the basic information, and then move on to some of the more management type problems we have with managing wetlands and therefore the carbon stocks. So wetlands accumulate organic carbon in their soil based on the low oxygen conditions caused by extended water saturation or inundation. Be aware that many wetlands dry out, some dry out completely and for many years, which changes the emissions and the retention quotient in these systems. Wetlands naturally emit carbon gases. They're part of the carbon cycle. They're part of the water cycle. We have to link these two together. But this makes wetlands among the most carbon-rich ecosystems of the world. But not all wetlands store large amounts of carbon. When we're thinking of wetlands and carbon, wetlands are all not equal when it comes to storing carbon. You have to look at the specific wetlands that you have and the hydrological conditions under which they exist. However, wetland degradation by human activities climate can cause emissions, I've basically said this, of carbon dioxide and methane, depending on the physical conditions in the wetland. Preserving wetland carbon stocks is seen as a key to halting climate change, to contributing to the efforts to halt climate change. It won't do it by themselves. But there is great uncertainty about carbon stocks and emissions and the ability of wetlands to maintain those stocks, which limits our management. So wetland maps and data have improved over the last decade in particular, and we now, there's an increase in the amount of wetland area we have, not because we've created or found more wetlands, it's just that we can measure them far more accurately than we did in the past. And there's issues of definition. We have to be careful what we call a wetland, and many different organisations who deal with wetlands or relate to wetlands use different definitions. So be very careful to understand what you're actually talking about. So we have very good, much better maps of wetland area. Some estimates being about 18 million kilometre squared, which 15, 20 years ago, we were only talking about 9 million. So we've actually, these estimates are important to understand it on an area basis. So we have, at the same time, increased our measurements of carbon. We still haven't, unfortunately, come across the totally standardized approach to measuring carbon, particularly in the underground parts of wetlands. To what depth do we measure? And if you look at the literature, a lot of people use different depths or don't actually sometimes even say. So we need to understand that carbon balance. But we do have, despite those problems, we do have increasingly better estimates of carbon storage or carbon stock in global wetlands. There's figures here. You can see the large range between 520 and 710, plus the permafrost soils, which are additional to what we call about the wetlands itself. Some people actually include permafrost data in the wetland data. So again, just being aware of what you're talking about. But if you look at these gross figures, looking at area and carbon measurements, being aware that there's some problems with measuring the underground carbon. Boreal wetlands contain by far the greatest amount of carbon that in global wetlands. Is a big drop back to tropical peatlands and mineral wetlands and temperate wetlands, as shown, just moving from left to right across this graph. There's been a lot of interest, a lot of attention to blue carbon wetlands, the coastal wetlands, those were affected by tides, etc. These actually occupy a very small amount of the total global area of wetlands. They have high carbon concentrations. The salt, etc., in the soil from the tides, etc., helps retain the carbon under certain conditions. So, but if you look at a global picture, a lot of our focus has been on blue carbon wetlands in recent years. There's a lot of very good science looking at that. But in the big picture, at a global scale, they are a very small part of it. So while I'm not saying, I would never say that we shouldn't stop doing that work, there's very good reasons to do it. And the first speaker mentioned the additional benefits of mangroves, for example. We need to move some of our effort or additional effort to the inland wetlands as well. Not all, by the way, are fresh. So we have another issue with the fresh salt issue in some of these wetlands, plus the one I mentioned before, the wetting and drying, which will affect the emissions, greatly affect the emissions. But we do have a lot better data, and we can see at a gross level the importance of wetlands globally, and that is based on a lot of individual measurements, etc. Now, unfortunately, wetland loss continues. Our best data is really from about 1970. There's some estimates back to the year 1700, which are modelled basically. But we understand that millions of hectares of wetlands, both coastal and inland, have been lost due to land and water management issues, changes in land and water use, for example. So wetland degradation is widespread in most regions, and globally it's due to land and water development, which is related to land use changes. So we understand this, we have a lot better information, and it's been going on for a long time. People value wetlands, people value degraded wetlands, which becomes our big management issue. Which value wins out in which place? The recent wetland declines are most notable in Latin America, the Caribbean, and parts of Africa. Degradation has also increased in other parts of the world. Some of this figures you have to again be careful of this information. Europe and North America, for example, they destroyed a lot of their wetlands centuries ago, or at least in the last century, if not before. These other countries, other regions, they actually have probably more of their wetland remaining than the other countries, but they've still got problems of managing it. So wetlands, unfortunately, are not well represented in international carbon policy. And there's a number of reasons for this. I don't necessarily think they're good reasons, which means they can be overcome, if you want to put it that way. The Ramsar Wetland Convention has, in my opinion, been slow to address the carbon issue, the climate change issue in wetlands. In recent years, they have looked at blue carbon, which is part of that great interest in coastal wetlands and blue carbon, which is a major step forward. But there's been an argument within this policy level at the international level as to who should address climate change, who should address wetlands in climate change. Should the Wetland Convention address it, or should the Climate Change Convention address it? Now, you could obviously say, well, perhaps they should do it together.
Well, yeah.
That's an obvious answer. It takes a lot of steps to get to that point. But the Wetland Convention, has not really addressed this until recently of the blue carbon. How do we get them to move to that next step? There is also inadequate data. While I said we have improved data, there is inadequate data in some areas. And in the recent past, I hope less now, we have overstated the importance of wetlands without having the adequate data. That is partly due because people are scaling up and not necessarily looking at the error or uncertainty that goes through with these scaling out exercises. So we need to be careful of overstating what we're trying to do, because if we're exposed, I think we lose in the end. And I've mentioned the blue carbon emphasis, high concentrations in small areas. So what's needed in terms of restoration and effective management? We want to maintain wetlands. We need to maintain the multiple values of wetlands, which has been one of the biggest challenges we have. We look at the global biodiversity framework, which has targets for restoring 30% of lost ecosystems, etc., and to repair degraded ecosystems. We look at this, and this is, again, big calculations. To restore 30% of lost wetlands, we need to repair and restore about 123 million hectares. That's a lot of area. And if we look at degraded wetlands, that adds another 350 million hectares. Now, if we drop to the next point, we've actually looked, and this is wide estimates again, looked at the cost of restoration based on what people have been doing. It's actually hard to compare across different economies, etc. The relative costs can be very different, and the effort or the type of restoration can be very different, very simple to very complex, etc. But there is a range which is going from, in international dollars, from $1,000 to $70,000 cost per hectare per year to restore these wetlands. Now, if you multiply out these figures of this range by the figures I've given you about the need to restore wetlands under the biodiversity framework, you see it's a lot of money, could be a lot of money. This analysis continues where they come back to a point which has been stated for many years now, since the start of the Ramsar Convention 50 years ago, if you come back to it. It's actually cheaper to maintain what we have rather than rely on restoration as the solution. But we have already lost a lot. So we need to go into restoration. It is where do we prioritize our restoration to get carbon or to get carbon benefits for restoration, for management to maintain the carbon benefits. In the restoration, we can restore wetlands. If we're trying to restore for any one benefit, we need to keep in mind it takes a long time to recover that benefit. By setting up a wetland which will absorb carbon, we won't get a replacement for the carbon that's been lost in a short period of time. It's a long-term venture. So when we're looking at these things, we need to have understand the time element, and which I think just, if you stop, think about that, pushes us back to saying, well, why destroy them in the first place? So actions needed by governments and communities. This is broad actions taken from various global assessments and from the Ramsar Convention. Key is protecting and conserving existing wetlands, being aware that not all are carbon rich. So if we're looking at carbon, which ones do we want to maintain for a carbon outcome, and provide policy and management practice for adapting to climate change. The Ramsar Convention and other groups have not come up with guidance on adapting to climate change in wetlands. I think that's an imperative which we could do. We need to prevent wetland destruction and maintain the carbon stocks, being aware of the dynamic between emissions and storage when we do that. So I think I said at the start, wetlands naturally emit carbon gases. It's part of the natural cycle. So we won't be stopping it. It's how we limit it and definitely don't make it worse. And no cheaper, prevent wetland destruction to maintain carbon stocks. Consider the carbon dynamics when restoring wetlands. It takes time to store carbon. Wetland restoration has been around for a long time. For decades, we've been trying to restore wetlands. And it's really, we weren't necessarily looking at carbon when we started. A lot of wetland restoration does not address the carbon issue. So make sure that is in there in appropriate places. And to finish, we need better data on emissions and storage. We understand the carbon cycle. We need to understand what is happening on local sites, locally. So what is the relevance of the data to the local management situation? We need to avoid overstating the value of wetlands because we may end up investing wrongly. So really understand the investment potential. And check, this I think relates back to one of the big issues, we need to check the double counting of carbon in national accounts. A lot of wetlands are included, could be included in the national carbon accounts through forested wetlands. So countries with forested wetlands, many of them have been counting forested wetlands as forests under their national accounts, not as wetlands. So to say that wetlands are not included is not quite right. We need to understand, though, what is included. And to finish, to help countries and local managers do this, we need to develop rapid assessment approaches to identify the priority sites for management and for restoration. So thank you.
Thanks so much, Max, and thanks so much for laying out the full landscape and its relationship to policy and policymakers, and also where we take into account wetlands and what the type of wetlands is and their capacity in the context of climate mitigation. Also, don't mix them up, forest and wetlands, but if we use forest as a way to account for our carbon sequestration, they have a different capacity than wetlands and forestal wetlands. So there might be part of that forest account, but not in the right way. And then you talk about costs, but the question, of course, is about value. Because what is the return of that investment? So I don't see it as a cost. I would argue against it because we invest in restoration and conservation and get quite a bit back. The question there, of course, is time. How much time do we have? We know that with the 3-degree world, which we're heading for, we will lose in 2100 10% of our global GDP at least. With a 2-degree world, we will limit that loss to 1%. So there is a real opportunity to change course. But the question is, the time to make the systems change and really help restore and conserve our natural system that will take time. Are we on time? So there's a lot of questions. Our speakers were more extensive than we programmed for, but were relevant in what we wanted to hear. We have some questions, so I'll do a first round short before we wrap this up in 14 minutes, because this is the time that we have. And I want to focus on the relationship towards policy to really translate your thinking into what is it that we can do. So for David, these trade-offs between forest conservation and restoration, agriculture and water security, and the hydrological cycle at large in the face of climate extremes, how can policy makers balance that trade-off? What is the opportunity that you see in the context of policymakers? Because our findings are key, but the question is what are we now going to do with it? David.
I guess I would focus on perhaps the question of agriculture and its use of the land resource, because one of the biggest declines in the evapotranspiration regime is essentially a result of agriculture, right? It typically leads to a reduction in evapotranspiration of somewhere around 50%. It varies a lot depending on type of agriculture and so on. And of course, this has a huge impact on the hydrologic cycle. And if we want to improve the hydrologic cycle across land surfaces, improve its watering potential and also its cooling potential, then we need to find ways to better integrate the ET regime into the agricultural landscape. And I think agroforestry as a model provides one alternative for perhaps moving in this direction, where we integrate more trees into the landscape and therefore more evapotranspiration into the landscape. But it's important to think about this. I mean, the conversion of the land use from forest to agriculture has significantly impacted the hydrologic cycle and the cooling potential of the land surface. And actually, it leads to more warming, rather, because we've lost all this cooling potential and watering potential. So that's at least one direction that I would want to go. I'm not sure I see contradictions or trade-offs per se, right? Because there are ways in which we can further develop these synergies to create a better ET regime, but still produce food for humans, and maybe do a better job of producing food for humans. Right. Because if we add more trees to the landscape, we have more water available for agricultural production purposes. So there are a lot of positive spin-offs that can result from this kind of approach.
I really like that, David. I really like that, because I think the avenue of finding those synergies taps into where we see mutual benefits. So change is hard, but if we can continuously and are able to show that there is an alternative, and with that alternative, we tick more boxes, to use that example, and really look across the whole system, it really starts to work. I think in this context, also important, as all three of you mentioned, look at the full hydrological cycle in its relationship to water, biodiversity, wetlands, and beyond. So I think that's great. Thanks. Max, there is a question on the chat specifically for you on Asia, as there is by Jane Lay. She said Asia seems less in decline on wetlands. Can we learn something is it an accident? Or can the world learn something from Asia? So that's one. The other, I would like you to tap into your cost and benefits part. You talked a lot about the cost, but the benefit in the context of how much time we have, and the scale of restoration versus the capacity that we have. So can you
I think just
expand on
that?
Yeah.
I think Asia shows some of the complexities and the nuances within these global or continental analyses need to come out. If you look at land clearing in China or in Asia, China and India with rice, for example, a lot of land has been cleared for rice production. It's still an aquatic system with a seasonal cycle, and it varies the amount of water that they use in different parts of those rice growing areas as well. So it's not a standard type of rice growing. There's a lot of different approaches. But there's still wetland values in having rice fields. But
Right.
a lot of that clearing, change of land use was done decades, if not centuries ago. So a lot of that's occurred in the past. Now, if you go to the tropical forest areas of Asia, there is more recent clearing, quite devastating amounts in some places, which is just ruining the peat-based systems, which are important carbon store. If you go to the arid part of Asia, there'll be less wetland loss because there's less wetland, basically.
Right.
So you need to break that apart and look at the different parts of the continent.
Right. Clear. Time. How far do we look back? Where do we look? And what do we look at? And to policy, when you think about the benefits and the time that we have.
Sorry, in the policy, I didn't get the question there.
So the policy implications makes, you talked a lot about costs, or a lot, you expanded on the costs, but if we are able to change course, there is these benefits. But the question is when do they turn up? Yeah.
Well, I mean, the biggest driver, David, I think, was getting at this as well. The biggest driver of wetland loss globally has been agriculture.
Right.
Therefore, it's food and fiber productions, not just food. And we need to be aware of that. Now, we're not going to convert food production areas, many of them anyway, back into wetlands as such. So it's really, how do we get those synergies and get some of the wetlands retained or restored in those areas for the high value benefits, which could be biodiversity benefits, but in many cases more likely to be benefits, the ecosystem service argument or nature's contributions to people, etc. And I think that is best done at a local level. So the policy needs to be localized.
Right. Thanks. Gets me immediately to Noreen. That local level, integrating local communities into decision making for water ecosystem management and beyond, especially when their livelihoods are directly tied to these systems. How can we? You have examples on your work and your research how we can tie these capacities better. What are some of your recommendations moving forward from your work and your experiences in this context, Noreen?
Yeah, absolutely. So interestingly, the region that I particularly did my doctoral work is an intermittent wetland in the northeast of Bangladesh, which is actually like kind of an intermittent lake where people have been living for centuries. And how rest of the country is like they look at flood as a natural disaster. People in this particular region have learned to live with those 6 months of monsoon flooding, and they welcome it. It's part of their life, and that's their indigenous knowledge. Is like, rather than building dams and trying to prevent the flooding, they have learned to live with it. But of course, with the more outside intervention or non-localized intervention, if I may call it, like that wants to prolong the agricultural season or agricultural activities, want to get more economic benefits, want to put dams, want to control the flooding and all that, where these people, what I've learned, are not, they take it as part of their life, which is the very beautiful part of indigenous knowledge, indigenous people, how they've learned to live in a synergy with these things. First of all, that I've seen, and they are more interested in, say, alternative livelihood, climate resilient livelihood, like boating and sustainable ecotourism that can, still have very low emissions, or, who look at different cropping patterns that does not particularly, like more resilient to climate shifting. So I see, like the value in the indigenous knowledge and their interests, and the respect and the honor that they have, they have for the nature and for the natural system, tapping into it, making them part of the solution really works, as what I have seen from my experience. And I think bringing those in policy, and I actually totally agree with David and also Dr. Finlayson, is that, localization and considering local context is the key, particularly for wetlands, given how different and how varying they can be and their storage capacities can be.
Thanks, Noreen. And I just want to say we have 4 minutes left, but we just got 5 minutes extra from the organizers. It was a little bit of a negotiation since your presentations were so extensive and we have questions on the chat. We want to make sure that we pay attention to. So thanks, Noreen. And again, tying this back. So before I ask Maria to wrap it up, I have 2 questions actually, both for Max. One is on the blue carbon wetlands in the way they differentiate from boreal wetlands in terms of storage potential and its resiliency. And the second question is the actions for government and communities for restoration and effective management you alluded on. What are some opportunities or business cases for the private sector contribute to this? So is there a private sector angle? And I think perhaps that's a question from Joshua, and the first was from Salma. Thank you both for asking that. But I think this goes to also Noreen and David. So the first is specifically for Max, but the second could be, what is the role of other actors than, beyond the government? But Max, floor is yours.
Okay. Yes. Very simply, blue carbons are coastal wetlands which are affected by salt, the ocean, the seas, or the tidal movement. They have salt, and it varies over the day with tides, etc. But there's that the salt actually affects the microbiology, which relates to the emissions. You don't get as much emissions from them. The boreal wetlands are freshwater wetlands and largely inland, and that had a whole different carbon cycle, and a lot of carbon dioxide naturally can come from them. If we degrade them, I think our first speaker said that, we get more emissions. So we've got to be careful with them. The other question about private investment, I think is a key. I go back to saying the governments can't do it all. And in many cases, people don't want governments interfering in their land management, which can have negative as well as positive outcomes. But I think government could incentivize or give good policy approaches to allow businesses, small businesses, even perhaps even large ones, depending on where you are, to invest in those ecological outcomes. In this case, to try and increase the carbon storage. Sorry, Hank, you need.
Yeah, I was muted. No, I was muted. My mistake. Never make the mistake when you're moderating. David and Noreen, perhaps also to you, the role of other actors beyond government, of course. And I think, David, you already expanded on, merging perspectives into an avenue of opportunity. This is the landscape where private sector comes in, of course. But please.
I think I would want to put an emphasis on the fact that while, I find it incredibly fascinating and encouraging to see all of the sort of ground level initiatives that are out there these days, in part as a part of the UN's decade of ecosystem restoration. But across all countries, there are really a lot of initiatives these days to try and improve forest landscape restoration, to extend forest cover. Sure, they could be better, but there are a lot of initiatives already on the ground. These are very favorable. But I suppose that my biggest concern as far as governance and management is concerned is that it almost never happens that these projects are considered in the context of this larger scale framework that I was trying to address in my presentation. So most of the projects are really local, small scale, and never try to seat these projects in a larger framework. What are the surrounding wind and weather patterns? Where is the moisture going to go that you produce by adding tree and forest cover to the landscape? Where is your moisture going to come from? And how has that been affected historically over time? And has it been depleted in important ways? I think this is perhaps the next step. I've been pushing for this idea for a long time now. But we haven't gotten there yet. And I think that's important to recognize, right?
Thank you. That's super helpful. Noreen, last, and then I'll jump to Maria. You're muted. You make the same mistake I made.
Oh, sorry. I'd like to answer one question. And thank you, David, for summarizing that one from Jalal Al-Karbuti. I think I'd like to answer that question, if you allow me, which is like what are the key lessons learned from flood management through restorations of aquatic ecosystems, such as rivers and wetlands, and how can these solutions be scaled up to enhance carbon sequestration and community resilience? This is my forte, so I would like to take this question and probably, say like Netherlands had the Room for the River project, which is actually kind of expanding the floodplains. Floodplains are very key wetlands that do sequester a lot of carbon are and have been globally widely disturbed for recreation purposes, for navigation purposes, for residential purposes, and I know for different reasons, agricultural purposes. So floodplains, and now we see that what Room for the River project is when you have your rivers have more wider floodplains and rooms, the water level doesn't go up that high during floods. Your water has, so it is a floodplain restoration project, which definitely kind of it reduces the flood risk, but also it restores and preserves the floodplains and the organic carbon stored in there. So it's like, don't tap the undisturbed floodplains. The floodplains that have been disturbed or degraded, let's restore them. And I think that is something that can be a very easy nature-based solution. I think that can be replicated and scaled up for both community resilience and carbon sequestration. So that's something I think you can look up. And then there's others too, like kind of eco-hydrological connections through vegetation, and I know which also helps with erosion and flooding and all that. So that's just something I wanted to bring attention to.
Thanks so much, Noreen. And I know we can talk about this for the next couple of days, and probably we will. And years. This was super insightful. Thank you for your inspiration, Noreen, David, Max. And now I'd like to hand it over to Maria Lindelien. She's a Senior Water Governance Officer at Water and Wetlands team at IUCN, currently in Switzerland, but on her way to Stockholm. Maria, please send us home. Thank you so much.
Thank you, and thank you to all the speakers and all the participants today. It's been a great kickstart to this week in this year's World Water Week. I'm not going to keep you for long. We've already gotten those 5 extra minutes, but I really want to thank everyone, especially for the richness of the perspectives that have been shared, and particularly for the deep dive into the science. And I want to encourage you all to join us for the next 2 sessions, at least those in Stockholm for the third one, which is going to be fully workshop, and then the second one, session 2, which is going to be also online, so those online can join for that, where we're going to go deeper into the practice and the policy of these issues. And so the session 2 is this Wednesday at 9 a.m. and then the third session, the workshop where we're shaping the path forward to these policy dialogues, will be Wednesday at 4 p.m. in Switzerland, and where we can look closer at these solutions and commitments that were highlighted by the speakers in looking at the policy and governance, the stronger integration of water and ecosystems into the national climate strategies and global frameworks, looking at local knowledge and participation of communities and indigenous leadership to designing lasting solutions, and most important, also very important, investment priorities, looking at the strategic investment and concrete pathways for actions, and these sort of opportunities that exist to really take this on hands-on and move with this in the coming years. So thank you very much.
Thank you all. Have a great day and Stockholm World Water Week, and look forward to catching up. And thanks all for joining from around the world. I think we have all time zones here. Looking forward to continue this conversation. Amazing.